Hello and welcome. This is Safa. In this video, we'll simulate and analyze the impulse response of an underdamped second-order system in MATLAB. I will show the code line by line, run the simulation, and then explain the waveform you see on the plot. Okay, this script computes the impulse response of a second-order system, a standard test to reveal a system's natural dynamic. First, I clear the command window with CLC, clear all variables with clear, and close any open figure with close all. This ensures a clean workspace and predictable result. Here, I define the system parameter K is the DC gain set to 1, omega n is the natural frequency 3, radians per second, zeta is damping ratio 0.3. Since zeta is between 0 and 1, okay, this is an underdamped case and we expect oscillation. Here, I create the Laplace variable s with TFS and define the standard second-order transfer function G. This is the canonical form for a mass spring damper style second-order model. Okay, and then I print the transfer function with this G. So you can verify the numerator and denominator in the command window. It helps confirm omega n and zeta are applied correctly. And finally, I open a figure and call impulse G to compute and plot the impulse response. I turn the grid on and label the axis so the plot is easy to read. Okay, run. Here you can see command window and here. Okay, now let's analyze the result. As expected for zeta 0.3 and omega 3, the response starts at 0 and immediately jumps to a large positive peak. In this round, the first peak is around 2. This is the impulse initial excitation of the system natural mode. After the peak, the response crosses below 0 and undershoot, here around minus 0.5. That negative swing is typical for underdamped impulse response. Okay, the waveform then exhibits several oscillations. Each successive peak is smaller. This is a damped oscillation. The amplitude decay exponentially because zeta greater than 0. Okay, and finally the response returns to 0, the natural steady state for an impulse input. The impulse response does not settle at a non-zero DC value. It decays to 0. Okay, this feature, okay, peak, undershoot, oscillation, exponential decay, reveal the system, natural frequency, and damping behavior. Okay. That's the impulse response for an underdamped second-order system. You can change here zeta to see overdamped or critically damped cases. Okay, and please check the GitHub link in description for the full code. Thanks for watching.